The three trig ratios allow us to express the relationship between the sides and angles in a right triangle. Our three ratios are the sine ratio, the cosine ratio, and the tangent ratio. The sine of this particular angle, theta, so in each case I'm talking about this angle for these diagrams, the cosine of theta, and I'm going to talk about the tangent of theta. The sine ratio is opposite leg divided by the hypotenuse. So for this particular diagram, the leg that is opposite of angle theta is y. So my opposite leg here is y, and the hypotenuse is labeled h. It's probably more useful just to remember that relationship. It's the sine is the opposite leg over the hypotenuse. And as you know, the cosine is the adjacent leg over the hypotenuse. And in this diagram, the adjacent leg is x, and the hypotenuse is labeled h. And finally, the tangent ratio is the opposite leg divided by the adjacent leg. And for this diagram, that would be y divided by x. The other review item that I'd like you to place in your notes today is the relationship between the three sides of a right triangle. We commonly call this the Pythagorean theorem. And it's a relationship between the two legs of a right triangle and the hypotenuse. Please label your legs leg 1 and leg 2, and the hypotenuse hypotenuse. And the relationship basically says that if I take one of the legs and I square that value, and I add to that the other leg, the second leg, leg number 2, squared, the length of that squared, I've got the length of the hypotenuse squared. So we'll use these two relationships in the following 4 examples. For example 1, we're going to find the length of the hypotenuse, which is labeled x in this diagram. For this particular problem, you can see that we have information about this angle. So we're putting ourselves in the point of view from this particular angle. At this angle, just as a review, we would call this side the opposite side or the opposite leg. This is the adjacent leg. And this is the hypotenuse. So we know that based on what we have the adjacent leg and we're trying to find the hypotenuse. So looking back at our notes, the trig ratio that deals with adjacent and hypotenuse is the cosine ratio. So we'll use that to figure out what x is. The equation we write is that the cosine of our 40-degree angle is equal to the adjacent side, 11, over the hypotenuse, x. It is here where I often see, we make some mistakes, and that's because our variable's in the denominator. My recommendation is that you always show this step. I am multiplying both sides by x. Again, if you have equal things and you multiply both sides by x, an equal thing, you get equal things. The reason why I do that is immediately now, if you look on the right-hand side, these x's cancel. I've got 1x in the numerator and 1x in the denominator. So this equation becomes x times the cosine of our 40-degree angle is equal to just the number 11. Now in order to get x alone, I'm going to divide both sides of this equation by the cosine of 40 degrees. And because cosine of 40 is now in both the numerator and denominator on the left-hand side, I'm left with just x. X is equal to 11 divided by the cosine of 40 degrees. When I plug that into my calculator and round to the nearest hundredth, I get that x is approximately 14.36. If you're not getting that value, probably because you are in radian mode, so please hit mode and make sure that you're set up in degrees. A 10-foot ladder is leaning against the side of a house. If the top of the ladder touches the house 9 feet above the ground, what is the angle made by the ladder and the house? So let's bring a little house here and put it right at ground level. The next thing we need is our ladder, and it's we're told that it's touching at a spot 9 feet above the ground. So I didn't mean that for it to be too large, but it looks good. So from the top of the ladder down to the ground, right, is a total of, this is 9 feet. And we're told that this is a 10-foot ladder also. And what we're asked to find is the angle that the ladder makes with the ground. So this is the angle that we're looking for, and I'll label it theta. So again, we need to use one of our three relationships between the sides and angles of a right triangle. I'm assuming that this is a right triangle. My assumption is that the house is not leaning to the left or right. It's perpendicular to the ground. So because I've got the opposite leg from the point of view of the angle, and I have the hypotenuse, the relationship here is opposite over hypotenuse is the sine relationship. So I can write that the sine of angle theta is equal to opposite over hypotenuse, or 9/10. So in this setting, what we're trying to do is find an angle, and in order to find the angle, we're going to undo the sine function. So we undo functions by using their inverses, and the sine function does have an inverse. If I apply the inverse of sine to the sine of theta, I'm left with theta on the left-hand side. And if I do the same thing to the right-hand side, I get the inverse sine of 9/10. So this is the symbols that you'll look for in your calculator. We want the inverse sine of 9/10. And if I, on my calculator, if I go ahead and press second function and then sine, it gives me inverse sine. And then I've got 9 divided by 10 for 9/10. And when I do that in degree mode, I get 64.2 degrees. So theta is equal to 64.2 degrees, and that's rounded to the nearest tenth. So that's the size of this angle that the ladder is making with the ground, 64.2 degrees. So find the perimeter of the figure below. We know quite a bit about the perimeter, right? We've got the 8, the 5, and the 5. The one thing that we don't have is this particular length right here, and I'll label it x. Once we figure out how long that is, we'll just add those four values together, and we'll have the perimeter of this. One of the things that I see is that because I have a square with a triangle popped on next to it, if I divide this segment up here, I've got the 5 from the square, and I've also got a 3. So I can see that I've got a 3 here. Also, this 5 would apply to this side also. So you can see what I've got here. I've got this right triangle in which one leg is 3, the other leg is 5, and the hypotenuse is x. So again, the Pythagorean relationship is if you take one of the legs, square it, and you add to that the other leg squared, you get the length of the hypotenuse squared. So I need to solve for x. To do that, I'm going to square 3, which is 9, and I'm going to square the 25. I'm sorry, I'm squaring 5, which is 25. And when I combine those two numbers, I should get 34. So that's what x squared is. X squared is 34. If I take the square root of both sides of this, I get these two values. I get plus or minus root 34 is the length of x. Now because this is a geometric setting, it's only the positive root that makes sense to us. And if I ask my calculator, what is the square root of 34? It will give me that as 5.8 rounded to the nearest tenth. So the length of the side is approximately 5.8 units long. Well, actually, these are feet. So I've got 5.8 feet. So the perimeter then is the sum of the following. The perimeter is the sum of 5 plus 5 plus 8 plus this one side that we just found, 5.8. And if I add those three up, 5 plus 5 plus 8 plus 5.8, I get the perimeter of that is about 23.8. And those were expressed in feet. So the perimeter is 23.8 feet. So for our final example, we have a right triangle again, and this time we're given the length of one of the sides, in fact the hypotenuse, and we're given an angle, the one labeled 42 degrees, and we're asked to find the length of the side that is opposite that angle. So again, here we're dealing with the opposite leg and the hypotenuse, and because we're dealing with the opposite leg and the hypotenuse, we're using the sine ratio. So the sine of this 42 degree angle is equal to the length of the opposite side, x, over the hypotenuse, 500. Now in this case you can see I do not have my variable in the denominator, and it's fairly straightforward to get my variable alone. I'm simply going to multiply both sides by the number 500. I'll probably choose to write it as 500 over 1 on this side, and on the other side I'll just write the 500 without the denominator of 1. I write that denominator of 1 because now I can see that I can cancel the 500 from the numerator and denominator on the right hand side, giving me just the value x. And over on the left hand side, all I need to do is grab my calculator and type in 500 times the sine of 42 degrees. I need to make sure I'm in degree mode. When I do that with this calculator, 500 times sine 42, I get 334.6. So I'll write x is approximately 334.6 units long.